again and welcome back to another video on FMOD and Unity, where today we're doing something really fun. We are going to look at how we can use a Unity project that's been integrated with an FMOD one to record your voice basically through your microphone in real time as you're playing your project. Before we start, if you haven't already, you may want to sign up to my newsletter, where I post little updates about what's going on with the channel, my website, and my online courses, which, speaking of, I'm planning on doing a pre-release for a brand new course, hopefully on the 25th of January. The course is based all on Unity audio, so it wouldn't be with FMOD. It's learning how to interact with Unity's audio engine via C#. So if that sounds like something you'd be interested in, then feel free to sign up to the newsletter. There'll be a link underneath this video which will take you to a little sign up page. Okay, so like I said, today we are looking at how we can create a script that is going to allow us to record our voice, or rather a player's voice if they're playing our Unity game, in real time and then play it back to them using FMOD and Unity. Now what I've done is I've written a script called Record Mic, and before I dive into showing you how it works, I'm just going to quickly test it basically, play it to you and show you, or give you an idea of what to expect. Okay, so game's playing, nothing's happening at the moment, but if I press space and talk, there you go. You can hear me speak twice because it's recording me and then playing it back straight away. I'm just going to quickly pause that because that's hard to speak with. But yeah, it's playing back through my microphone, which if I quickly turn my camera, that's the microphone I'm using right now. Through that, it's recording my voice, and then through Unity, it is playing it back basically, as close as it can do to real time. Now what it can also do, if I press space again, hello, there we go, just to continue it. If I then press the enter button, it's really hard to speak, you should now hear, hey, a big reverb all of my voice. I stopped that, that's really hard to talk. But yeah, that's the idea. And by the way, for the record, let me quickly play it again. As you can see, if I minimize Unity, and this, I've got nothing else open recording. So when I say this is Unity playing it and recording it, you can take my word for it. This little script I've made, like I've just demonstrated, is designed to play back whatever the microphone's picking up in real time. Hopefully from this script you'll be able to take some ideas and maybe integrate this into some projects, or maybe even design a game around this idea. And I'm hoping in future videos I could do like additional parts to this video and expand on this idea a bit more, because there's a lot you could do with this, and the script I've written I've made it as simple as I can, because there's a lot of complex, shall we say, ideas or ways of interacting with FMOD's API that we haven't yet looked at, but there's a lot more that we can do with it, and that would be a bit more practical, say, for a game. So hopefully in the future we can dive into some more ways of, recording something with a microphone, then playing it back through Unity in more practical ways that might help you out. Right, okay, so before we dive into the script itself, let me quickly show you how you would interact with the script in Unity. So the first thing you do is would choose a recording device to use. Now you may have noticed that some text appeared in this box when Unity was running. Well, that's actually telling us which recording device we've selected. Now, you select your recording device with an index, which is basically just a number. So depending on how many devices you've got plugged into your PC, depends on the range, will increase the range of the index. So my computer detects about 4 or 5 recording devices. I think 3 of them or 2 of them are just software devices, and they're actually a bit useless. I can't really record with them. There's 2 main microphones basically I've got plugged in to my PC. That's my desktop Rode shotgun mic I've just shown you, and also the one on this webcam. So what I'm going to do is I'm going to change that index from 0 to I think 4, which is the one that represents my webcam mic. And by the way, I figured out that 4 is my webcam mic just by trial and error. I've set the script up to actually tell us the name of the device so we can see which device we're recording with. But let me hit play and do some more recording. There you go. So you can see now the microphone name is now microphone Papalock microphone, which is the name of my webcam called Papalock. Now if I press space, ooh. So you can hear the quality's dropped. Because obviously hold on, let me stop that. That's really hard to speak. Obviously the quality on the microphone on my webcam is a lot worse than my shotgun mic, so yeah, you can notice it. What you may have also noticed is with that first recording when I was using my good microphone, you were probably only hearing the recording through one channel, either your left or your right, depending on how you're listening to this. Whereas with that, you were hearing it on both. And the reason why is because in our script, you'll see in a second, it reads your recording device and it determines whether or not that device is recording in stereo or mono, so 2 inputs or 1. My microphone is obviously recording with 1, so it plays back 1, right? And it plays back 1 channel through both channels, or rather 1 recording through both channels, so the left and the right. With my good microphone, and I don't get this on any other, in my DAW or anything like that, but it thinks it's recording a stereo input, so it thinks really there should be 2 microphones there. So it's playing my shotgun mic through my left ear, and then nothing through my right, expecting another microphone to be there. And I'm not really sure, that's definitely not to do with my script, that's to do with how I've set up my interface. So blah, 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 that's why that was happening. And I'll show you how we can actually see that, how we know that the script is kind of detecting how many inputs each recording device has in a second. But yeah, so that's how you select your recording device. I'm going to change that back to my main microphone. You've also got a latency option. So we can't, unfortunately, just, play the recording back as soon as we've started recording, because we'll get some errors. We'll hear some weird kind of artifacts that sound all grainy and horrible. It needs a little bit of time to take that recording, store it in memory, process it basically, and then play it back to us. It needs some latency, which is what we can adjust here. So I've set mine to 1 second, but if you need more, if you start hearing weird stuff, you can just increase the latency. And finally, we've got the place where we select the buttons. So we can choose a button to control playing and pausing the recording. We've also got a button to choose how to control the reverb. And yeah, that's pretty much to it, nice and simple. Okay, and I think that's everything for interacting with the script in Unity, so let's open it up and see how it works. By the way, if you want to just copy this script and paste it into your project, I will have a link underneath this video in the description, or as a card in the top right corner. That will bring you to this page, and you'll see a little option for copying and pasting the script that we're using now. It's not there yet because I haven't uploaded the video, but by the time this video is up, you'll see a little, you'll see the video and the script underneath it. So yeah, feel free to copy it that way. Okay, so what I'll do is I'll quickly run you through these variables, basically, explain what their purpose is. So this top section here is all of our public variables, i.e. all of the variables we were interacting with within Unity. So we've got, and these here are headers just so we can organize it a bit better in Unity. Don't have to worry too much about those. So the first one is our recording device index, i.e. choose a number and it will choose a recording device for you. Then the recording device name is that big text box that tells you the name of the microphone you're recording with. I've added this attribute in front of it, text area, which just makes it nice and big so we can see it a bit better. Then we've got the latency, so we can select a number, and that will give us a bit of time between when the microphone actually picks up our recording, process it from analog data to digital, and then plays it back from digital to analog. And then finally, we've got 2 variables of the key code type, and this allows us to basically bring up that menu we saw earlier where we could choose a key. And like I said, this is for playing and pausing the recording, as well as turning a reverb effect on and off. Under that, we've got some FMOD objects that we are going to interact with in this little lesson. The first one is called sound. This is basically going to hold our recording and also what we're going to interact with mainly in order to tell it to play. Now, normally when we are using FMOD, we're interacting with things called events rather. If I jump into, I don't even have it open, 1 second. Let me open the FMOD project I'm using for this. Okay, here we go. So this is the FMOD project that I'm using with the Unity project. And as you can see, it's pretty bare. There's actually nothing going on other than a quick test event I created. And that's because we don't really interact with the FMOD software as much by recording our microphone anyway. We don't really need to interact with the actual software like we normally would. As you obviously know if you've watched this channel a lot of times, what we normally do is create an event, add a sound file to it, and then through Unity we tell that sound file to play. Well, because we're kind of recording our own stuff, we don't really need to use events at all. So it kind of means we don't use any of this really. So yeah, going back to the script, Normally we'd write something like, in order to play an event in FMOD, we'd create like an event instance variable, and then we tell it to play and stop and start and all this stuff. We don't really need to do that. What we need to do instead is use a different part of FMOD's API, which is this bit here, the sound object. So we create a variable we create a sound object by writing FMOD.Sound and then giving it a name. I've called mine sound. And optionally we can make it public or private, but we don't really need to make it public, so I've just made mine private. The next variable is called xinfo, and it is of the fmod.createSound xinfo type. That's a bit of a mouthful. Now, my understanding of this is a little bit vague, but I'll explain what I do understand about it. Basically, this kind of variable type serves as a way of storing certain information that will then feed into our sound object to tell it how it's going to record through our microphone. It will give it information such as a sample rate, number of channels, and some other stuff which we're going to see in a little bit. But yeah, in order to get this working, we need both of these variables. And yeah, like I said, I'll explain how this works in a bit more detail later on. Finally, the last two variables we have under the FMOD object section here is a channel variable and a group channel variable, or a channel group variable. As you can see, we declare them by writing fmod.channel and fmod.channel group, and then just give them names. And I've just called them channel and channel group. Now, the way this works, what we're going to do is once we've recorded through our microphone, we've got a sound, we're going to send this sound through a channel. That channel is then going to go through a group channel. Now, let me quickly explain what channel and group channels are within FMOD's API. Basically, you can have group channels, right? And what you can do is you can send multiple channels into those group channels. Once you've done that, you can then send a group channel or multiple group channels into a higher group channel, if that makes sense. What it's basically doing is allow you to control the signal flow of your project through the FMOD API and through your scripts. If I quickly jump into FMOD quickly, basically if I click on this little test event I'm not really using, every event, right, has an output, okay? Makes sense. What we can do with FMOD's API is we can take this output, we can store it inside one of these group channel variables for us to measure or even do stuff like add effects to, so that the sound that goes through that event or the output of that event will have an effect applied to it. And we can add that effect in the script, as well as, we can obviously do that in FMOD, but by using these we can add the effect, through our programming. So maybe we wanted to set it up so the effect is applied at a certain point in the game. And yeah, it doesn't just stop at events. If we had buses like this bus here, we can also do the same thing, take their output and store it in a group channel variable. And then what we can do is we can, oh, whoops, that's OBS. We can then send these channels into these group channels, and therefore we can send certain sounds or even events into buses. And like I said, it basically gives you control over the signal flow of your project via your script. Now, when it comes to using them with this sound object and the sounds we record through our microphone, we're not really going to be using them too much. We're literally just going to be telling the sound to play through this channel and therefore through this group channel. Basically, they're going to end up through the master bus here at the end. I did want to try and find a way of setting it up so that they run through a bus first, so that we'd have a bit more control over them and maybe add some effects that way. But I struggled, to be honest. I don't know. I thought I understood how these work, but clearly I'm going to need to do some more research. So apologies if that's something you'd like to do. Moving on, we've just got two integer variables here. So these are just going to hold numbers. These are going to hold the values of, or the amount of, devices we have hooked up to our PC that we can record with. Now, for some reason, FMOD can take it can give us two numbers. It can give us a number that represents the number of drivers and the number of drivers connected to our PC. Now, not sure what the difference between those two are. If we've got drivers on our PC, I don't see how they're not connected, if that makes sense. And whenever I've done testing, the number is always the same between these two. But nevertheless, those are the two different numbers it gives us. So we've created two different variables here, which later on we're going to store those numbers into. So yeah, they're also private. Again, you can make them public. Doesn't matter. That's optional. Now, all of these variables here are basically going to hold information about the device we're using to record with, right? So once I've said, okay, I want to record with my good shotgun mic, and we start running, what FMOD or Unity, I suppose, will do is it will check my device or my driver, and it will basically store certain information in these variables. So the number of channels, for example, as I mentioned earlier, the microphone on my webcam just records one mono, so that'll be one. But with my audio interface and the shotgun mic I've got plugged into it, even though I've only got one mic plugged into it, it thinks there should be two, so that will be two, for example. You've also got sample rate, so with my shotgun mic and my audio interface, that defaults at 48 kilohertz, so that's what that number will come out as. And then we've also got some other FMOD specific options. So this is the FMOD speaker mode. So we declare this variable by writing FMOD.speaker mode. It's basically another way of saying how many channels have we got. So if this was given a value of 1, the speaker mode would be mono. If this was given 2, it would be stereo. And if it was 5, it would be 5.1 or so on. Now, as you'll see later on, we have to have all of these variables, but the two we're only really going to be interacting with the most is the sample rate and the number of channels. But like I said, we'll look at that in a bit more later on. Finally, we've just got some other variables. These are all Booleans, as you can see, so they're only going to be true or false. DSP enabled is kind of like a switch if we want to turn on our effect or not, that reverb. Play or pause, again, another switch if we want to play the sound or pause it. And finally, play OK basically acts as a measure. It kind of measures that latency I mentioned earlier of a second. Once a second has passed, it switches from false to true and says, okay, you can now play back the sound if you want. Okay, so that's all the variables we will be using. So let's move on to our first function, the start function, which we know runs as soon as I press play. As soon as the game starts, it's gonna run once on the very first frame of our game. Now, what I've done hopefully to break things up a bit and help you understand, I've made some notes. As you can see, this is the green text here, displaying all the steps, the process we're going to go through in order to get this to work, as well as some of the functions that come with FMOD's API, what their purpose is and stuff. So let's look at step one. Step one is to check to see if any recording devices or drivers are plugged in and available for us to use. So obviously, if we're going to record anything, we need to check to see if we've got any microphones available. So what we do is we use this line of code here. Now, what I've written is at runtime manager.coreSystem.get record number of drivers. This is the function here, get record number of drivers. And what it's going to do is basically find out for us how many drivers or recording devices are plugged in and attached to our PC, and then it's going to store them somewhere. Okay. Now, you might have to write this. You might have to include FMOD Unity at the beginning. Now, the reason why I don't, and as you can see there as I typed it, it turned grey. It turned from white to grey. The reason why I don't need it is because at the top here, I've included it as a namespace. So if you want, you could do the same. We're going to be using functions within the Runtime Manager class, which is another script that is basically installed into your Unity project when you integrate FMOD into it. And we're going to be using other functions from within it a lot in this little script. So it's just to shorten the script a bit, save me writing this out every time. I've included it at the top there as a namespace, so feel free to do the same. But either way, whether you're using it as a namespace or not, you need to write runtime manager.coreSystem.get record number of drivers. And then in the brackets of this function, we need two variables. Now, as you might be able to see there, this function will, like I said earlier, it will give us two numbers. It will give us 1, the number of drivers, and 2, the number of drivers connected to our PC. Again, I don't know what the difference is, but I don't know, maybe there's some cases where you can have drivers that aren't connected, maybe disabled, because obviously drivers are a certain software that process analog recordings or sound and then process them to digital and then play them back and then do the conversion again from digital to analog, right? So maybe, you know, some of the drivers you've installed on your PC, you can have, I don't know, switched off or something, and that's why some of them will be connected and some of them won't. But either way, yeah, we need to place those numbers somewhere. So that's what these variables at the top here are. Number of drivers and number of drivers connected. So we say, okay, so output the first number into the number of drivers variable at the top there, and output the second number into number of drivers connected. So these will change from 0 to, in my case, 5, because I have 5 drivers installed on my PC. Once we've done that, what we want to do is check the number of drivers connected. That's the important one. Obviously, for us to interact with them, we need to know if they're connected or not. We don't care about the ones that aren't. So we just check to see if the number of drivers connected is 0, then we display this message in our console. I've put, hey, plug in a microphone, you dummy. Because obviously if there's no drivers connected, we can't do any recording. If there isn't, or if there is a driver connected, if there's more than 0, then we just have this little message telling us how many drivers we do have connected. So this is just a little kind of test, basically, a little way just to make sure that we can actually record before we do anything. Okay, so now that we know how many devices are connected to our PC, we need to pick one of them and take some information from that device, basically, as that will be the device we're recording with. And we do that with this function here. So we are runtime manager.coreSystem.getRecordDriverInfo. And as you can see, there is a lot of information going in and out of this function. So let's break it down. Okay, so the first thing we do is give it a number. This number will represent the device we've chosen to record with. So in my case, I can choose 0 for my good shotgun mic or 4 for my rubbish little webcam mic. Now, you might have to do a bit of well, first you might have to use this script and do some testing, basically, to see, number one, how many recording devices you have, and 2, which ones you can record with. I suppose I could have written something here that would have actually displayed in Unity the number of devices. Oh wait, I did, you idiot. Do you know what, screw it, I'm keeping that in, we're running with it. So yes, once you played the game and you know how many devices you've got connected, you can then choose a number between 0 and that number. And then by doing that, you'll be choosing an index. Then in Unity, you just pop it in the record device index and boom, you're away. You've chosen a microphone to use. Next, the function is actually going to give us loads of information about that driver. So the first thing you can see it gives us is the name of the microphone we've picked. So that's why I'm using this variable here, record device name. If I scroll up, again, that's this variable I mentioned earlier, the one with the big text area. That's where I'm storing basically all the string data, all the characters that this function is going to output. Now, as you can see, I've written out in front of it. Now, the reason why is because some functions, some of the fields within a function, they need you to give the information to the function. So, for example, this recording device index, it's asking for a number to be given to it. But in this case, it's telling us that it's giving us some information. Therefore, we need to write the keyword out to kind of say, okay, that information you're giving us, I want you to output it to this variable. Okay, so that's what that means whenever you see out. Now, the next piece of information it needs is it basically needs to know how long the name of your microphone is. This is a bit of a weird one. It basically needs to know how many characters it needs to, I guess, put aside for holding or storing the name of your microphone. If that makes sense. Long story short, this number here that I've written 50, that's going to be how many characters I can store within my recording device variable, which is going to hold the name of my recording device. So you could change this number if you wanted to. You don't really need to. I've just picked 50 because it's a nice big number, and some microphones, when they're connected to audio drivers and interfaces, and you've got a whole big setup, they can be really long. So, you know, that's why that's 50. The next thing is, well, to be honest, we don't really need to worry about it too much. It basically just says that we need to store some information inside a system.GUID variable. So that's why we've declared one up here and called it mic_GUID. So once again, as you can see, we've used the keyword out because for this to work, it needs to output this information. This is a variable that we're actually not going to interact with at all from this point on. It's just to get this function to work, it needs to put this information somewhere. So despite the fact that we're not going to be using it now that we've got it, we still need to include it. We still need a place to store it. So that's what the purpose of that variable is. Next is the sample rate. So this is going to give us a number which basically says the sample rate at which the microphone you're using is going to record at. So I've stored mine in a variable called sample rate, which is an integer. So it's holding, it can hold whole numbers basically. And yeah, that is a variable that we're going to be using later on. So that's important. Next, FMOD speaker mode. Like I said earlier, this kind of FMOD speaker mode is a way that FMOD kind of writes down the type of well, speaker system you've got set up, or basically whether or not you're recording in mono or stereo. So once again, that needs to be outputted somewhere. So that's why we have this variable. And again, that's one we're not going to be interacting with too much later on. Next, number of channels, that gets outputted into the number of channels variable we declared earlier. So that 0 is going to change from, say, 0 to a 1 if it's mono, 2 if it's stereo, and so on. And finally, the driver state. This is another variable that, well, it's just information, again, that we don't really need to worry about. It just needs to go somewhere. So that's why we created an fmod.driverState variable and called it driver state. Now, before we move on, what I'm going to do is quickly just double check I've saved this script. And I'm going to jump back into Unity. And I'm going to play the game one more time. But this time what I'm going to do is I'm going to come up to the top right corner here. Hopefully you can see that. There's like 3 lines on top of each other with a little arrow next to them. I'm going to click on that. I'm going to click debug mode. And what this is going to do is show you all of the variables in your script that are private and wouldn't normally be shown or interacted with. i.e., it's going to show us all those variables we've just taken all that information from that function and stored. So if you were playing your game, you did want to check all that information, you could do. So if I hit play, you can see that some of these fields have been filled out. So the number of drivers connected and the number of drivers in total, both 5, that's there. The sample rate is 48 kilohertz. Sorry, yeah, 48 kilohertz. The speaker mode is stereo. Like I said, what mic have I selected? 0. So there you go. Because I've left it at 0, the microphone is my line-in M audio track, blah, 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 blah. It's my good shotgun mic, basically. And like I said earlier, the way my interface is set up, it thinks that 2 should be recording, but I've only got 1 plugged in. So yeah, stereo it is. Number of channels, again 2, because it's expecting 2 inputs. Driver state is mixed. Now we could find out what that mixed actually represents, I guess. If I went back into the script and I changed this variable to public, we could then interact with it and look at that drop-down menu. But we're not really, like I said, this is information, half of this is information that just needs to be stored somewhere we're not going to be using. So yeah, that's there. And if you do want to find out, you know, what sample rate your device is at and stuff for testing purposes, you can by clicking debug. Simple. Okay, so next is step 3. Now that we've got all that information about our driver or our recording device, we need to basically store it in a format that we can use with our sound object. Again, that's the thing that we're going to be, or is going to be holding, I suppose, the recording we create, okay? Now, we've got all this big block of code here, right? This is all step 3. Now, before I dissect this, I want to show you something basically. If I go to FMOD and go to the FMOD download page, we have the option here to here we go, to download FMOD's Studio and Core API. Not only does this allow you to download the API, but it also gives you some examples of what you can do with the API. So I downloaded, I forget which version, one of them. I downloaded one of them, and yeah, I basically had a look at those examples. So if I go into my desktop on my PC, I go to my local disk, program files, I'm going to scroll down to FMOD.Sound system, FMOD Studio API Windows, I'm going to go to API, it's a lot I know, stay with me though, Core, examples, and here we go. So these are some scripts, some examples that the developers of FMOD have come up with using their API with C++, not C#, C++, in say Visual Studio, right? And there's 2 here called record and record enumeration. So using these 2 scripts, basically they've created examples of what you can do using the idea of recording a microphone during runtime of your program. If I scroll up and open bin, we can actually open the executable files created from those scripts. So let's say if I open record, yeah, just record.exe. Oh, there you go. So look, this is the little kind of, oh, I'm closing that straight away, it's so hard to talk. So what you just saw there was a program that the FMOD developers have created using C++ and their API to record your voice or your input from your microphone and play it back to you live at runtime, basically what we're trying to do in Unity. And it also shows you some fancy numbers for latency and stuff. And yeah, the second one does a similar thing, but this actually allows you to record and start and stop basically. So I can start recording, say a load of nonsense, and I can stop it and then play it back. And I can But that one's a bit weird because it records for like a fraction of a second and loops it. I don't know why it does that. I don't know if that's a mistake on my part on theirs, but hey, there's 2 little examples of, you know, recording with a microphone using FMOD. But yeah, forget about that. We're not interested in the actual executables. We're interested in the scripts because we can open them up and take a look at them within Visual Studio. Now, in order for me to learn how to do this within Unity, I copied a lot from these scripts and no idea how I did it, but I translated basically what they had written in C++ into C#. I guess they're very similar, aren't they? The reason why I'm telling you all this is because step 3 I copied from the script pretty much exactly. bar changing a few things. So my understanding of it is a little bit shaky. I'm still trying to learn it myself, but I will try my best to explain to you how this works. To do that, I'm going to quickly scroll up first, and I'm going to go to here where we created our xinfo variable, and I'm going to hold Control and click on the actual type of it, create sound xinfo, and open it up. So as you can see, what this is a struct, and it basically holds loads of different pieces of information. And as you can see, the information and the type of information and their purpose is all laid out here, so we can actually have a look through it, right? Now, like I said earlier, what we need to do is take some of that information we took from our driver or our recording device and put it in some of these fields, not all of them, thankfully. So I'm going to quickly go back to my record mic script and scroll back down to step 3. So the first thing we need is to fill this field here, CB size. Now, if I go back into that script I just opened up by clicking Control, by holding Control and clicking on the Create Sound xinfo type, it's in the top right corner for me, I can read what CB size is. So let's scroll along. So this is the size of this structure. This is used so that the structure can be expanded in the future and still work on one of old versions of FMOD.EX. What that means, I have no idea, but basically by writing all this nonsense, which I figured out works by, do you know what, I don't even know, because that's different here. Long story short, did some trial and error, read the documentation, and eventually figured out that by writing all this, it works, okay? What I also found out is that alternatively, you could just write the number, not 31, the number 32. And the reason why is because what it's asking for is, it's asking for the size of this struct, this type, create sound xinfo. So let's click on it one more time. By size, it means how many fields, how many pieces of information can it hold. And if you count all these down, you'll find there's 32 of them. Now, I don't know why it needs to know this, but it does. Next is number of channels. That's a nice easy one. It just needs the number of channels that our driver is going to be recording with, okay? So that variable, which we, remember earlier we used the get record driver info function, and that found the number of channels our driver could record, stored it in the number of channels variable. Well, we're now feeding that number back into the xinfo variable via the number of channels field, okay? Next, it needs a type of format that you're going to record with. Now, you can decide on a format by using the FMOD.Sound _format enumerator. There's a few options. If I quickly get rid of PCM16, you can choose between PCM 16, 24, 32, 8, blah, blah, blah. There's a few options. 16, I just saw being used in the documentation and in their examples, and it makes sense, doesn't it? We don't need a really high quality format to record into. We just need something that's going to be efficient and not take up too much memory within our PC. So yeah, just write that, FMOD.Sound _format.PCM16. Next, it needs a frequency. For this, we just give it the sample rate of our device, which again we got earlier from the get record driver info. So that's going to give it the number 48,000. Now, the last thing we need to give this variable is a length, i.e. A certain amount of size. How much data are we going to dedicate to our recording? Because obviously in this needs to know how much space in memory it's going to create or dedicate to our recording. Now, this confused me a little bit because originally I wrote out what you can see here, and I'll explain what all this means in a second. And it produced basically a number, right? We're just multiplying a load of numbers together. And that number was, say, 96,000, okay? After a while, if I recorded, I would notice that after a second it stopped. But if I increase the number, so say if I wrote multiplied by 10 here, so we now get 960,000, we could record for longer. So that meant, okay, the longer the length, the more sort of space in memory we've got, the more I can record. Makes sense, right? But now, even though I haven't changed this, now I can just record infinitely, it seems. So let me know if you have that issue when you copy the script, if you notice that after a while it just stops recording. It might be to do with this length. I'm not 100% sure because, like I said, now it seems to work regardless of the number. But either way, what you can see in front of you is another thing that I've copied from the original record C++ script. So it takes the frequency, the sample rate, takes that, multiplies it by the channels you're recording with, and it also multiplies it by this, size of short. Let me quickly go back to my script. Now, size of is a specific kind of thing within C#, Unity, and C++, where you can give it a data type, and it will give you the size in bytes that that data type takes up in memory every time you use it. So some data types, for example, let me scroll up to our variables. Some data types include the integer data type. By the way, these are only value data types, so things that hold numbers essentially. So the integer integer type is a data type, a value type. Float is another one that holds numbers as well, and so on. There's also some, if I scroll back down, called unassigned integer or uint. That's another one, and they're all basically whole numbers, but they're all slightly different for certain reasons. They can hold, some of them hold more numbers or bigger numbers, some of them hold smaller ones, and they all take up different amounts of space within memory. Now, by writing size of short is another value data type we can store numbers into. We are basically saying multiply these two things here by whatever the size of this data type short is in data, in bytes, right? Now, the answer to that is 2. For every short, you basically take up 2 bytes of data. So, again, I don't know why we don't just write 2, but hey-ho. Like I said, this part I don't understand 100%, so I'm still learning. And yeah, that's what that means. As for these bits here, these I do believe I know what they mean. So if we go back up to our sample rate variable, that is an integer. Now an integer variable can only hold a number between, I think it's minus 2 million and something and 2 million and something. I'll make sure I display it on the screen because I can't remember off the top of my head. But yeah, that's the limit. We can't hold a number bigger or smaller than that range. Now the unassigned integer, it can hold the same amount of numbers, if that makes sense. The range is the same, but it's shifted so that it can't hold any negative numbers. So now the range is between 0 and 4 million and something. Again, I'll double check and put that up on the screen for you. Now, if I scroll back down to length, you should be able to see here that it will take an unassigned integer or a number in the form of an unassigned integer, i.e. a number that is between 0 and 4 million. Now, whilst our sample rate and our number of channels do sit in those range, they're stored within integer variables. And the reason why, if I scroll back up to this function here, the getRecordDriverInfo function, that was, as you can see here, that wanted to output those pieces of information, the sample rate and the number of channels, into an integer variable. It wouldn't let us store them anywhere else. So that's why they're in integer variables in the first place. But yeah, to get them to work, we need to change them from integer variables, or not change the actual variable, but when we input that information into here, we just need to, sugar, I've just forgotten the name, I feel like I just said it, apologies if I didn't, but basically we need to change the numbers into a different type, if that makes sense. So simply by writing 2 brackets in front of the variable and the data type we want to change them into, typecasting, that's what it's called, we could do that. We could basically change them into a type that the length field of our create sound xinfo variable, which we've called xinfo, can accept, okay? And yeah, that's everything. So now we have all the information we need stored inside the xinfo variable for us to use. So let's move on to step 4. Okay, now this is where we create the sound object itself. We're going to now initialize it so that we can start storing a sound into. So to do that, we write the function create sound, which we can access again from the Runtime Manager class. And as always, it needs some information. The first thing it needs some user data. It needs to know, I think, anyway, this is my understanding of this, it needs to know where in memory this sound is going to be saved to. Again, I'm not too sure. There's a lot of concepts here that deal with memory and really dive deep into the program of Unity and FMOD. So apologies for not understanding that 100%, but what I do know is by basically using that variable we created earlier, the xinfo variable, we can pass in this field called user data into this first section of the create sound function. It'll accept that and it will work. And what that does is kind of link the two together as well, I suppose, too. The next thing this function needs is to be given an FMOD mode. Now these FMOD modes, as you can see here, FMOD.loop normal and open user. Again, if I scroll here, you can see this is what they've done with the record script in C++. So I've used the same ones, just written them out so they work with C#. Now what you could do, again, this is something I'm a little bit sketchy on how they work, but what you could do is you can go to the FMOD documentation, which I'll have linked underneath, and it will tell you the purpose of all these different modes, or flags I think they're also sometimes called. Now loop normal, it just says for forward looping sounds, I guess it loops it. But FMOD open user, which is the other one we're using, I think we're using both, by the way. You can see it says opens a user created static sample or stream, and it uses that variable type we used earlier, create sound x info, to specify the format, default frequency, number of channels, blah 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 blah. Now in general, I think what these modes do is decide how the sound is going to be sort of stored, not only stored but kind of loaded in and out of memory. So feel free if you want to kind of experiment with some of these. I've been as well. And see what works and what doesn't. The next thing we need to do is, again, give it our variable that we created earlier that has our driver information, ex info. We just need to write ref in front of it. Whenever you're passing a variable into a function like we are now, and you need to include ref in front of it, that basically means that the function can change the original data stored within that variable. If ref wasn't there, all it'd be able to do is simply take it and use it for something else, right? But that's the purpose of ref. It means the function can change stuff within ex info. That's not necessary for us to know in this context, but just in case you're wondering what that means. Finally, the last thing we need to do is give it a sound object to output all of the magical, complicated data that it's been messing around with into for us to use. So as you can see, we've used the sound. If I scroll up to the top, the variable we called sound, or the sound object we created earlier, which later on we're going to be recording into. So now this has kind of been initialized, primed and ready for us to use. Okay, so next is step 5. And from here on out, my understanding of how this script works starts to get a bit better. So here we go. Now, we're using a function. This function is called record start. Pretty self-explanatory. We're going to start recording now. We access this function from the Runtime Manager class, i.e. to get it working, we write runtime manager.core-system.record start, and then follow it with 2 brackets which we feed it 3 pieces of information into. First, we need to feed it the index of the device we're using to record. Are we using my rubbish webcam microphone, for example, which was 4, or are we using my good shotgun microphone, which was 0? Next is the sound object that we had just initialized. Where is this recording going to belong, basically? Well, it's going to belong in our FMOD.Sound object that we created. Now, finally, we need to give it a true or false value. Do we write true or do we write false, depending on whether or not this recording loops? Now, let me explain what I think that means. I mentioned earlier that I had some trouble originally with the length of the sound. It would record for, say, I don't know, half a second and then stop. But I could increase that by increasing this number I fed here, okay? By multiplying it by a larger number. What I think this is how this works. Basically, what will happen if we set this to false, this will, we'll start recording through our mic. Then once we reach the limit of our length, but whilst we've recorded the amount of so much data that this fills up, for example, I mentioned earlier that I think the length we set to about 96,000 bytes by feeding it this. Once those 96,000 bytes are filled up, then it can't record anymore. However, by setting this to true, what we're saying is once that's filled up, you can basically get rid of that, empty that sort of, empty that variable out, this ex.length thing, get rid of all that data so that we can start recording again into it. So we're kind of getting, the way we're able to just record endlessly without our memory filling up is by, well, doing just that. As we record, we dump some of the old recording data that we've just played back, and we create this kind of loop effect. I think that's what that means, and I think that's how I think that's how we're able to constantly keep recording. That's my understanding of it. Again, what I'm going to do is link in the description parts of the documentation. Here you can see this explains how the record start function works. Maybe you can make heads or tails of it and understand it better than I can. Feel free to give it a go. Okay, so wicked, we're recording. Now, last thing to do is to basically start a coroutine. We want to delay the time it takes before we play it. So what we're using is a coroutine. Coroutines in Unity allow you to basically wait a certain amount of time. Well, they let you do a lot of things, but one thing you can do with them is wait a certain amount of time in seconds before you execute certain amounts or particular parts of your script, right? So what I've done is I've created this enumerator, which I guess is a coroutine. I've called it wait, and this doesn't get called, as you can see here, until all of those other steps we just went through are finished. So now we're recording. Now is when this wait enumerator is triggered. So now what it's going to do is it's going to wait for a certain amount of seconds. The amount of seconds it waits depends on the number that we gave to our latency variable. Again, that was a variable that we could interact with in Unity. So it takes that number and it waits for however many seconds. For me, it's 1, right? So once it's waited 1 second, that's when it plays the sound, okay? So we record here. As soon as we've recorded, we trigger this coroutine, which waits for a second. Then it tells our system to play whatever it's recorded. So let's have a look at how it does that. So it uses this function here called play sound. As always, all these new functions we've never used before come from the runtime manager class, .core system, and then you write the name of the function. This needs 4 pieces of information to work, so let's run through it. First, it needs the sound object that you're recording into, which again, ours is just called sound. Next, it needs a channel group. Now, let's scroll back up. Like I said earlier, these channel and channel groups you can use with the signal path within your FMOD project. Now, it needs a channel group to work, but other than telling it, use this channel group variable, I've not really hooked this up to FMOD in any way. I've not told it to, hook up to a bus or the master bus or anything. So I guess by default, if you create a channel group, and if you don't do anything with it, it just plays it through, or it hooks it to the master bus, because that's as far. Like I said, I don't understand how it's working, but it is working simply by just sticking it there. The next thing it needs is a true or false value. This dictates whether or not the sound is going to start paused or start playing straight away. Now I've started mine at true, so therefore it's going to start paused. We're not going to hear it straight away. And the reason why is because obviously I've set the script up so that we can control whether or not it's played or paused via the press of a button. So once this starts playing, I don't want it to start playing straight away. I want to give the person using the script control. So that's why I've started it off as paused. Later on, we're going to see how we change it to unpause, basically. Finally, we need to output the sound into a channel. Okay, so this goes into that channel variable that we created earlier. Again, it's not hooked up to anything, so I assume that it's defaulted to pass through the master bus. Other than that, that's pretty much all you need to do to play the actual sound. Next thing I've done, now that we're playing our sound, I've changed this variable, this Boolean variable, play OK, to the value of true. This is just basically, it's like a little indicator. We're just saying, hey, we've waited enough time, we've set everything up, we're now recording, we're now live, and as you'll see earlier, we'll use this kind of flag as a way of giving us control over the player pause, and not until we've set everything up. That second that latency is waited and things are ready to go. Finally, we've also just got a little debug.log message just displaying in the console saying ready to play. Again, telling us that we can press whatever button we want to play our sound. Okay, so now we're moving into the update function. So all of that we just explained happens once, but here everything is going to happen, or at least be checked on every frame that's run within Unity. Okay, so step 7, now that coroutine has been run and our sound is playing, we now need to check whether or not we've pressed the button or not to play back the recording to our player. So I've got this little if statement here. I've written if input.getKeyDown, and then inside getKeyDown is a function, by the way. Basically, if you give it a button or a key, it will check to see if that key has been pressed on a particular frame. Now, obviously earlier we created a play and pause variable of the key code type, and we made it public, which means that in Unity we can choose from there which key we want that variable to hold, right, and it to be represented by. So back in the update function, if that key that we chose in play and pause is pressed and our flag that we created, that Boolean variable, play OK, is true, then we can pause or unpause our sound depending on whether or not it is paused or unpaused. So the first thing we do is take the play or pause variable. This is another Boolean variable, you'll remember. If I scroll up, we declared it at the top here, and it starts off as true, okay? So when the game starts, it starts as true. We take that and we flip it to whatever it's not. So play or pause, we set that to the opposite of whatever it is, represented by that little exclamation mark in front of its name. Then what it's going to do is we're going to take that channel that we're passing our sound into, we're going to use this set pause function, and we're going to take the value within our play or pause variable to, well, play or pause our sound depending on what it's doing. So the very first time we press our button, we know it's going to be paused, because if we scroll back up, you'll remember we set the sound to true, to pause as soon as it's playing. So play on pause is going to be set from true to false. Then using the set paused function, the sound is also going to be set from true to false. So basically we're unpausing it the very first time we press that button. Then the second time we press the button, it's going to go through the same process, but the value is going to be swapped. So play or pause will start as false, but then be set to true here. Then the value true is going to be passed into the set pause function, and thus pausing our sound, so we won't be able to hear it anymore. Finally, we have step 8, which is an optional step. We can decide whether or not we want to add a DSP effect to it. So again, we've got another if statement checking to see if a button or a key is pressed on a particular frame, which again will control whether or not we switch our sound from having this DSP or reverb effect to not having it. So if it's pressed, we create two variables called prop on and prop off. The reason why they're called that, well, to be honest, again, I just copied them from the record script. So we've got these two variables of the FMOD.Reverb_properties type. Now, what we can do is we can store a type of DSP effect that is pre-programmed within FMOD's API into these. So the one that I've stored in prop on is called concert hall. By the way, we access those different reverbs by writing fmod.preset and then write the actual name of the reverb that is classed as in FMOD. And if you want to change the reverb, what you do is get rid of that, get rid of it to the dot at the end, press the dot, and it will give you all the options, all the different kind of presets of reverb that we can set our sound to. So I'll tell you what, let's mix it up a bit. Let's go room? Yeah, let's do, hopefully that's kind of a smaller reverb. I'm also just going to add 2 brackets at the end. There we go, so it works. Then the second variable we created of the reverb properties type, we've set to another specific reverb, but this reverb is basically nothing. It's called off, okay? So this is dry, basically. Underneath that, we have our DSP enabled Boolean variable. Again, if I scroll up, we declared that here in our sort of other variables section, and it starts at false. This acts in the same way as, it's basically the same method we used here for the play or pause. Whenever this button is pressed, this variable is going to swap from true to false. It's going to swap to its opposite, which is what the exclamation mark indicates, okay? And depending on that is whether or not we're going to turn the reverb on or off. Now, to actually do that, to actually tell our sound to add reverb and take reverb away, we use this variable, sorry, this function here, set reverb properties. And this is the last function we're using from within the runtime manager. The first thing it needs is an instance. I'm actually not sure what that instance represents, but there you go, it's set to 1. And the second thing, I should have looked that up before I'd done this video. In fact, I can, I'll tell you what, give me 1 minute. Okay, so if we have a look at the set reverb properties function in the FMOD documentation, it says the instance is the reverb, references the reverb instance index. And if we click on here, it says it ranges between 0 and whatever the max amount of reverb instances are. I guess there's a certain amount of reverbs that you can have. There's a limit. I suppose that's what that means. But yeah, either way, by just writing the word number 1, that works. Moving on. Next thing we do with this function is we feed it a reverb that we want to use. Basically, we feed it a variable of the reverb properties type. Now, as you can see here, once again, we have to write ref in front of these because these can be changed by the function. That's not too important, though, to understand. What is important is what this question mark is doing. Now, this question mark, it's like a clever way of creating an if statement. Basically, it's going to first check the value of this Boolean variable. As you can see, whilst the function here is asking for a variable of the fmod.reverb properties type, we've not given it that. We've given it a Boolean variable. But next to it, you can see the name of our 2 variables of that type. What this question mark does is check to see if this variable here, DSP enabled, is true or false. Depending on whether or not it's true or false, it will give it one of our 2 fmod reverb properties variables. If it's true, it's going to give it whatever variable we wrote on the left side of this colon here, you can see here. So this colon and this question mark work together. The one we gave it on the left side, if the DSP enabled Boolean is true, is the prop on variable, which is holding our preset, our reverb preset, which was room. If DSP enabled is switched to false, then it's going to instead feed the set reverb properties function with this variable here, prop off, which, as we know, doesn't hold a reverb. It's just a blank preset with kind of default reverb settings, which I assume is just wet, nothing, dry, everything. Yeah, so that's how that works. And with that, that's everything with the script. Now, that was a really long video to go through, so thanks very much if you sat through that. Thanks also for waiting on me to make a video. Like I said, this takes ages. But one final time, let's play this. Let's have some fun. Let's also listen to our new reverb that we've just added to it. Okay, so one final time. My index is 0, so you can see it's looking at my interface and the microphone plugged into it. If I press space, you hear my voice. And if I press enter, you should hear, hey, my voice of a reverb. So that's a lot shorter. Reverb than the other one. Oh God, that gives me a headache every time I do that in my voice back. But yeah, like I said, that is everything. Thanks very much for watching. Let me know if you want to see any other videos in this particular style. Like I said, I'd love to do more looking at the what we can do with recording a microphone at runtime, because I have some unfinished business with this API. There's a lot here that I don't understand that I would like to learn about. And there's a lot also that I think we could do with this. So let me know if you'd like to see more of this, or if there's anything in particular you'd like to see me do with this idea of recording at runtime. And also just in general, if there's any kind of audio programming stuff you'd like to see from me. Don't forget, as always, go to my fancy dancy website where you can sign up to our newsletter, find out about all the updates that's coming to this channel and the website as well. I want to add a lot more. I want to do more basically with this website and this YouTube channel this year. So fingers crossed they can. And yeah, feel free to sign up. Okay, I've been Henry Scott. Thank you very much for watching, and I will see you in the next one.